first section on quadratics. I'm going to give you a little bit of background about what a quadratic is, very briefly. And before I do that, I'm just going to tell you a little bit about linear graphs. So linear curves, as the name suggests, are straight lines, and you may have come across them already in the form y equals mx plus c. And we know a little bit about these already, I hope. That is the gradient, and c is the y-intercept. So an example might be y equals 3x plus 2, where here we've got the gradient is 3 and the intercept is 2. And these two characteristics of the curve tell us a bit about what it should look like. So if I have a set of axes here, x and y, then there's my intercept on the y-axis, y-intercept, and there's my line, which tells me every one across I go up 3. That's from the definition of the gradient being the rise over the run. So you should know a bit about that already. And now we're going to move on and look at quadratics. Now, these are often in the form y equals a x squared plus bx plus c. A, b and c are just numbers, and they will tell us some of the characteristics, just like m and c tell us about the straight line. These will tell us about the characteristics of the quadratic. So an example could be something like this, where we've got 2x squared plus 3x plus 6, actually. Let's make that minus 6. You can have a negative there. All the numbers a, b and c could be positive or negative. And if you've got a positive value of a, the coefficient, in other words the number in front of x squared, coefficient of x squared is positive, then you'll have a curve that looks like a U. And if it's a negative value of x squared, in this case we're positive, but if it was negative, you would have an N shape. Now, this particular one, if you were to plot it using a table of values, which is the most common method, and you might have come across that in earlier modules, would look something like this. This here is still the intercept, just like it was before. So I know it goes through at minus 6. I know it's U-shape, and I would have to do a little bit more drawing, working out to get it, but I know it looks something like that. It should be symmetrical. I've not done such a good drawing there. Now, that's essentially what a quadratic is. It's a curve, and it can tell us all sorts of things depending on how we use them, and it's quite a big area of maths, so it's useful to be able to handle them. And by handle them I mean doing things like expanding, factorising and solving quadratics, and we'll come to those in later sections in this unit. For the time being, I'm going to concentrate on ones where the x squared coefficient is equal to 1. So it might be something like this, for the sake of argument. Notice here the coefficient is actually 1. It's not 0. If it was 0, there would be no x squared at all, and it would just be a linear system, just like we started with at the top of the page. But here we have got an x squared coefficient of 1. So we're going to have a look at factorising them and expanding them, and some special cases in the later sections.